Today's lesson is still about the coordinate plane, and the essential question is, how can we use a coordinate plane to find the perimeter and area of polygons? So what's the difference between area and perimeter? It's kind of what I want you to think about and remember. And so pause this video, write down in your own words what you think the difference is. And then I'll show you, you should have written something like this. Area is how many square units are in a two-dimensional figure, and the perimeter is the distance around the outside of a figure. And remember for perimeter that the units are just one dimension because you were literally measuring one dimension. And remember, area is the square units that you would count inside the figure. Okay. So, of course, in order to find the area and perimeter, we need to go through and make sure that we remember the formulas for all of the different figures that we worked with so far this year. So we have a rectangle. Remember, area is length times width. So then I would label this part would be the length and this would be the width. And then for a parallelogram, hey, it's just like a rectangle. It has a length and a width, but we call it the base. And remember, the height is the distance that is perpendicular to the base. So area of a parallelogram is base times height. And then remember, a triangle is half of a rectangle or a parallelogram. So the formula is base times height divided by 2, or 1/2 base height. And in this picture, I could draw this would be the base. And the height is the distance that goes straight from the top and is perpendicular. And then, of course, the trapezoid is a little more complicated. Remember, a trapezoid has two bases. I'm going to have to move this formula over. It is 1/2 height times base 1 plus base 2. So I could call this base 1. This side would be base 2. And this would be my height. And so the perimeter of a rectangle, right? So the area of a rectangle is length times width, and the perimeter of a rectangle is the distance around the outside. So there's a bunch of different ways you could write this. So I could write it with a capital B, perimeter. Literally, I could just write L plus W plus L plus W, right? You're just traveling around the rectangle, counting the distance around the outside. But then if I have 1L plus 1L, I could also write it as P equals 2L plus 2W because you have two lengths that you're adding and two widths. Or you can think about the distributive property, and maybe we could be a little more sophisticated and use some parentheses and write perimeter equals the length plus the width times 2. Remember when we did the distributive property, we multiplied the 2 times everything inside, which makes it look like that formula. Okay, so those are the formulas that we learned this year and we're going to keep using. So what do you think we're going to do next with that formula, and what do you think we're going to be doing on a coordinate plane? Think about it. Let's do it. So I'm giving you an example that says the vertices of a rectangle are, and there's 4 points, right? So what I want you to do is I want you to draw the rectangle and find the area and the perimeter. So I'm just going to start with F1, 6. Now, you can notice that there's no numbers on my coordinate plane, right? Sometimes what I like to do is just to make some space, right? This has to be the origin right here. So I could go ahead and label this 0, 0. And then maybe each one of these hash marks is going to be 1, but I could skip and I could just label 2, 4, 6, and 8 just to make the graph a little bit less messy and complicated. So the F is 1, 6. Remember, I start at the origin. I go over 1. I go up 6. I make my point and I label, right? I want to label each of the vertices of the rectangle I'm going to draw. And then G is 7, 6. So I go over to 7 and I go up 6 and I make my next point and I label it with a G. And then H is 7, 2. Start back at the origin, go over 7, up 2, and then J is 1, 2. Back to the origin, over 1, up 2, and there's my J. Now you want to use your straight edge on your paper, and you're going to connect the vertices. Okay, so now we just drew a rectangle in the coordinate plane. And remember, if we are finding the area and the perimeter. Of course, what we need to get, oops, trying to move this box. Don't know why that's not working right now. Okay. What we need, of course, is we need the length and we need the width. So I'm going to look and I'm going to call this the length, right? Remember, I start at 0 and I count 1, 2, 3, 4, 5, 6. The length is 6 units. The width is 1, 2, 3, 4, 4 units. And the area is length times width. So it's 6 units times 4 units. And I get 24 units squared for the area and the perimeter. Maybe I'll use my fancy formula, 2 times L plus W. So I'm going to write 6 units plus 4 units times, 2 times 2. 6 plus 4 is 10 units times 2 is 20 units. And remember, it's not squared because I'm just measuring a one-dimensional length. Okay, so that's the basics of what we're doing today. Now we're going to get a few more complicated shapes. So try this Oyo. This is in your record and practice journal. So if you want to do this in your RPJ, it is problem number 2 on page 94 in the RPJ. So you're going to draw there's 4 vertices, so you can bet that it's going to be a square or a rectangle, and then find the perimeter and the area. Go ahead and pause the video. I'm going to continue on. D is over 3 up 2. E is 3, 7 over 3 up 7. There's my E. F is 6, 2. I go over 6 up 2. And I put an F, and G is 6, 7 over 6 up 7. So there is my G. And then I'm going to connect these and make a rectangle. So the length is 1, 2, 3. I've got 3 units. And my width is 1, 2, 3, 4, 5 units. Area equals length times width. So I'm going to do 3 units times 5 units equals 15 units squared. And my perimeter, P equals 2 times L plus W. So I have 3U plus 5U times 2. This is a total of 8 units times 2 equals 16 units. Okay, so this is 16 units around the outside, and there are 15 square units inside. Okay, so this is really cool because when they do archaeology sites, they actually have a grid system that they put on the ground so that they can catalog things that they find. And so notice in this one, it says that each unit represents 1 meter, right? And you guys know the square meters, what it looks like. Picture a meter stick, right? That's how long it is, and that's how wide it is. Okay, so this one's already drawn for me. I do need to connect the points because it just makes sense to go around the outside. So I'm trying to find the dimensions of this secret chamber here. And the length is going to be 1, 2, 3, 4, 5, 6. Now, because I told you that it's 6 meters, you don't want to use units. So I'm going to abbreviate with an M for meters. So the length is 6 meters and the width is 1, 2, 3, 4. The width is 4 meters. Find the area and the perimeter. Area equals length times width, which is 6 meters times 4 meters equals 24 meters squared. And the perimeter equals 2 times L plus W, which is 2 times 6 meters plus 4 meters. I get 10 meters times 2. So the perimeter around the outside is 20 meters. So now let's look at a question that's a little bit different. So let's say you find gold. You find a gold coin at -1, comma 0. So I'm still going to make my little grid, right? So you can see the grid that we had before. This is from the previous problem. Now, this, I'm going to do this in yellow for gold, right? So negative 1, 4. So I start at the origin, and I go negative 1, 4. So this is where they found a gold coin. And then they said they found a silver coin. So let's grab a silver color. So this is going to be a silver coin at negative 4, 2. Remember, I start at the origin, and I go in the negative direction, and then I go up 1, 2. So right here is where they found the silver coin. So we'll do S for silver, and this one will be G for gold. And then we have some pottery. So let's just make this brown. Pottery at negative 4, 4. So we go over negative 4 and up 1, 2, 3, 4. This is where they found P for pottery. Okay, and now I'm going to move this over because I realize you can't see all of that. Okay, and I'm just going to erase these colors here. So they do the dig and they find these three things, pottery, gold, and silver. And what it says is how much closer is the pottery to the silver coin than to the gold. So if I'm trying to figure out how much closer the pottery is to silver, then I want to look at that distance. So I'm going to write the distance from pottery to silver. So if I count the distance from pottery to silver, if I start here, it's 1, 2, right? So that's 2 meters. Excuse me. Then to the gold coin. So I want to find out what the distance is from the pottery to the gold coin. So pottery to gold is, so if I start here and I count 1, 2, 3, it's 3 meters. Here's the question. How much closer is pottery to silver than to the gold? So it's 2 meters to the silver and it's 3 to the gold. So basically what I'm doing is 3 minus 2 equals 1 meter, and then I'm answering the question like this. Pottery is 1 meter closer because it's 1 meter less. Okay, so now I have an OYO, and I'm asking you to draw and label the polygon, and you're going to first find the length and the width, and then calculate the area and the perimeter. So go ahead and pause the video, and then I will show you my work. So over 3 up 2, that's where A is. Over 3 down 3 is where B is. C is negative 1, 2, so I go over to the left and up 2. There's C. And D is negative 3, negative 1. I'm sorry, negative 1, negative 3. And that is D. So I'm going to go ahead and connect the points and make my polygon. And then, of course, I'm going to find the length. 1, 2, 3, 4. The length is 4 units. And the width is 1, 2, 3, 4, 5. 5 units. Area equals length times width. So I do 4 units times 5 units, and that equals 20 units squared. And then the perimeter is 2 times length plus width. So I have 2 times 4 units plus 5 units, which is 2 times 9 units. So I get 18 units. Okay, so we have another polygon that you're going to be plotting. Notice that there's only 3 points. So if there's only 3 points, then you know you're going to be making a triangle. So I'm going to show you this example, and then you're going to do an OYO. So the triangle, let me move this over so it's more on the screen. There we go. So A is 2, 2. So it's the same idea, but I'm just going to be using a different formula because a triangle is half of a rectangle. And then B is 2, 6. There's my B. And C is 5, 2. So I go over 5 and up 2. So you might recognize this as a right triangle because it has a right angle right there. So this is my base and this is my height. So even though it says length times width here, what we're doing is we're finding base and height. Right, so I'm going to do base and I'm going to do height. So the base is 1, 2, 3 units and the height is 1, 2, 3, 4. Remember, the area of a triangle is base times height divided by 2. So I plug in 3 units times 4 units divided by 2. And I get 12 units squared units squared. Okay, so here is an Oyo for you to try. This is a rectangle. Oh, I'm sorry. I don't know if it's a rectangle. You'll have to plot it and find out. Pause the video. I'm going to go over 1, up 2, and plot L. M is 3, 5 over 3 up 5. N is 5, 5, so I go over 5 and up 5. And O is 7, 2, so over 7 up 2, and there's an O. Okay, check it out. Not a rectangle for sure. This is a trapezoid. And so remember, for a trapezoid, you need you need the 2 bases and the height. So we're just going to drag this over here. That's not what we need. We need B1, we need B2, and we need the height. So base 1, I'll call the top. It is 2 units. Base 2 at the bottom, so this will be my base 1. This will be my base 2. And the height is the perpendicular distance from the top to the bottom. So B2 is 1, 2, 3, 4, 5, 6. The height is 1, 2, 3. Oops, let's put units. Okay, so my formula is, I'm going to run out of room here because I don't have a whole lot of space. It's B1 plus B2 times H divided by 2. So I'm going to leave off the units just to make some room. So I've got 6 plus 2 times 3 divided by 2. So 6 plus 2 is 8 times 3 is 24. Move that down. I get 24 divided by 2, which equals 12. And remember, it's area, so it's units squared. So there's a trapezoid, there's a triangle. As long as you can find the dimensions that you need in order to find the area, it's not that different from how we found the area before we started plotting on a coordinate plane. Okay, so I just thought I'd show you this for a challenge. There's some vertices of a triangle, right? And so I'm giving you A and B, and I'm trying to get you to figure out 4 possible coordinates of the third vertex so that the triangle has an area of 24 square units. So I'm going to go A is negative 6, 3. 1, 2, 3, 4, 5, 6. Down 1, 2, 3. Okay, so here's A. And B is over 2 down 3, 1, 2, 3. So right now I have 2 vertices, and I can think of this as being the base of the triangle. And here's what I want you to think about. Remember that the area of a triangle is base times height divided by 2. So I can work backwards, and I can think about making a rectangle that is twice the area of the triangle. So if the area is going to have 24 square units, right? So the triangle equals 24 units squared. The rectangle that I can make the triangle out of has to be double that, which would be 48 square units. So I'm going to just think about this. If this is one side and I count 1, 2, 3, 4, 5, 6, 7, 8. So this is the base, and my base equals 8 units. So think about where I could put the third vertex so that the area of the triangle is 24 units, and the area of the rectangle that the triangle is made from is 48 units squared. I'm just going to pause the video and see if you can think about it and maybe think about where you would put the vertex. Okay, so hopefully I'm just going to point out a couple of easy ones. If you have the base, if you think about a rectangle, if the rectangle is 8 times 6, that would give 48, right? So I can put, if I make this the side of the rectangle, I count up 6. 1, 2, 3, 4, 5, 6. Oops, 1, 2, 3, 4, 5, 6. So if I put a point here, now I'm just going to show you, I'm not going to draw this rectangle, but I'm going to put a point here and here. If I completed the rectangle, this would be 8 times 6 is 48. So what I could do is, if this is my vertex, this is half of the rectangle. The rectangle is 48, so I know the area of the triangle is 24. So this point here is over 2, 3, right? So it's 2, 3. And then I'll make this one in red, because I thought these would be the easiest for you to see. If I go down this way and then this way, now I've made the red triangle also 6 times 8 is 48, and when you divide it by 2, you get 24. So I can go up from here, but then you know that I can also go down in that direction. I just thought it would be kind of a fun thing to look at. So that's today's lesson, and good luck on the homework.